In this lecture here, we want to continue talking about dividing polynomials by talking about synthetic division. Now, this is kind of like an algorithm approach for how you divide polynomials. Now, it's going to seem really, really weird when we first do it, okay? But I promise you, if you stick with it, it's actually one of the quickest and easiest ways to do division. So this synthetic division works when you have a polynomial divided by something that looks like this. Just some x minus c. So this synthetic division is not going to work. Let me just go back. When you have something like this, notice how there's a 3x plus 4. It only works when you have an x plus something or an x minus something. Okay, so it doesn't work in this case here. And so what I want to do is I'm going to walk you through kind of this this process with an example here. Okay, so it's going to seem confusing, this algorithm. So here'll be the first example. Let's take x cubed minus 6 minus 7x, and let's divide it by x plus 2. All right, so the first thing you're going to have to do, so notice even how I said this, like it needs to be x minus c. So just note, if you have something that looks like x plus c, like in this case here, where I have x plus 2, this is the same thing as x minus c. So if you have something like x plus 2, you write this as x minus 2. So in this case, your c is minus 2. All right, so the first thing you're going to do is you're going to take your polynomial and you're going to arrange it in descending powers with a 0 coefficient for any missing terms. Okay, so what that means is, notice how I have x cubed here. Okay, so I'm going to start with x cubed. Do you notice how I have no x squared? So I'm going to write this as plus 0x squared, and then minus 7x. Oh, a little bit of a typo there. So x cubed plus 0x squared minus 7x minus 6. And this, I'm going to write it as divided by x minus 2. Okay, so I get this x minus c. The next thing you're going to do is you're going to set up this table, and it's going to look a little weird at first, but you're going to write c for the divisor, okay, x minus c to the right, and the coefficients of the dividend. What the heck does this mean? So you're going to set up a table using this synthetic division. So it looks a little weird. You're going to set up a table that looks like this. Kind of looks like an L. You're going to take this c and you're going to put it right here in the table. And then up the top of this table here, you're going to put the coefficients of your polynomial. So the coefficient here was 1, then a 0, then minus 7, and then minus 6. All right, first thing you're going to do is you're going to write the leading coefficient of the dividend on the bottom row. So the first thing you do is you take this 1 and you bring it down. All right, that's always the first thing you do. Then the next thing you're going to do is you're going to multiply c times the value just written on the bottom row. Write the product in the next column in the second row. So what you do is you go minus 2 times 1. So you go minus 2 times 1 gets me minus 2. Then what you're going to do next is you're going to add the values in the new column, writing the sum in the bottom row. So you're going to go, okay, now let me add down. So what is 0 plus minus 2? You get minus 2. Next, you're going to repeat this series of multiplications and additions until all columns are filled in. Okay? So now you got a new number here. So you're going to go minus 2 times minus 2 gets me plus 4. Now watch what happens when I add down. I get minus 7 plus 4 gets me minus 3. And then my last step here, I'm going to go minus 2 times minus 3 gets me 6. And then minus 6 plus 6 gets me 0. So I have these new numbers down here. So use the numbers in the last row to write the quotient, all right, plus the remainder above the divisor. Okay, so here's what this means. The degree of the first term of the quotient is 1 less than the degree of the first term of the dividend, and the final value in this row is the remainder. Okay, so this right here is our remainder. Anything in the last row is our remainder. Okay, so we see the remainder is 0, so it doesn't work. I mean, not that it doesn't work, it's just that there's no remainder, okay? Sorry about that. So we started with a cube here. So what I would do here is I would put an x squared here and then an x. So this becomes 1x squared, which is just x squared, minus 2x, minus 3. So it's like, oh, did that really just work? So let's check. So if I take this x plus 2 and multiply it by x squared minus 2x minus 3, like what happens? Okay, let's see. So I get x cubed minus 2x squared minus 3x plus 2x squared minus 4x minus 6. Well, look, x squareds cancel. I get x cubed minus 3x minus 4x minus 7x minus 6. So it checks out. So this process worked. It's good. All right, a little confusing. Let me do another one here just so we can see this process. Let's take 4x cubed minus 3x squared plus 3x minus 1, and let's divide it by x minus 1. All right, so this is x minus c. Okay, so when I set this up, I don't put minus 1 over here. Okay, this is important. It's x minus c, so my c is 1. And then cubed, squared, x, and then a constant. So I just bring over the coefficients, which is 4 minus 3, 3, and then minus 1. So follow the algorithm. First thing you do is bring the 4 down. Boom. 1 times 4 gets me 4. Minus 3 times 4, or minus 3 plus 4, excuse me, gets me 1. 1 times 1 gets me 1. 3 plus 1 gets me 4. And then 1 times 4 gets me 4. And then minus 1 plus 4 gets me 3. So notice how I started with the cube here. So this becomes x squared x. So this becomes 4x squared plus 1x. Or I should have just wrote an x, but I put the 1 there. Plus 4. And then my remainder I write as a fraction over the divisor. So plus 3 over x minus 1. So I'm just gonna, so it's 4x squared plus x plus 4 plus 3 over x minus 1. Notice how quickly this goes once you understand this process of synthetic division. It can go boom, 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 really, 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 really quickly. All right, let's do a much longer one now. Okay. All right, so let's try this one. Let's look at x to the 7th plus x to the 5th minus 10x cubed plus 12, all divided by x plus 2. All right, notice how I start with the 7th, but I'm missing a 6, a 4, a squared, and an x. So you can even just rewrite this as x to the 7th plus 0x to the 6th plus x to the 5th plus 0x to the 4th minus 10x cubed plus 0x squared plus 0x plus 12. Oh, wow, a lot going on here. Divided by x minus 2. Okay, just changing that over again. All right, so let's set up the lot of synthetic division going on here. A lot to do. So my c is minus 2. And now let me bring down the coefficients. It would be 1, then a 0, then a 1, then a 0, then a minus 10, then a 0, then another 0, and then finally a 12. Okay, follow the algorithm. First thing you do is you bring down the 1. You go minus 2 times 1 gets me minus 2. Add down. 0 plus minus 2 gets me minus 2. Now minus 2 times minus 2 gets me 4. 1 plus 4 gets me 5. Minus 2 times 5 gets me minus 10. 0 plus minus 10 gets me minus 10. Negative 2 times minus 10, what does that get me? That gets me 20. Minus 10 plus 20 gets me 10. Minus 2 times 10 gets me minus 20. Okay, 0 plus minus 20 gets me minus 20. Minus 2 times negative 20 gets me positive 40, right? So then 0 plus 40 gets me 40. And then minus 2 times positive 40 gets me minus 80. And 12 plus minus 80 gets me minus 68. So what did we started with? We started with a x to the 7th, so this is x to the 6th, x to the 5, x to the 4th, x cubed, x squared, x, and then this is the constant and the remainder. So the solution is x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40. And then our remainder here would be minus 68 over x plus 2. So imagine trying to do this, with long division, right? So the synthetic division, just boom, boom, boom. You can do it really, really quickly whenever you have something, just an x plus or minus some value. All right, class, as always, you'll get a chance to practice this. And the more you practice, the easier it will become.